Thank you for that introduction. Well, let me just, I'll just share my entire screen if I can, and I'll just jump straight into this presentation. All right. So today I want to talk about, I've tried to use a bit of alliteration, 3 R's here: robots, revenue, and recreation. But the story really is about the way that programming, programming skills or data science skills can affect all aspects or touch on all aspects of our work and our life and our recreation experiences. So on the robots side, we can see that there are useful robots that are slowly becoming parts of many industries. And I don't just mean that we have automated machines like dishwashers and washing machines and dryers and microwaves. We've had those for decades. I mean, we're getting reprogrammable robots that are slowly becoming abundant or slowly being introduced to replace human labor in ways that in the past wasn't really practicable. It wasn't that they couldn't be done. It's just that there were too many problems in real life scenarios that was easier to teach a human to do. But these new robots, yeah, they're more useful than the machines of the past. They are, as I said earlier, they're reprogrammable. So we're finding that we're able to teach them to do new things rather than just solve a single problem like a dishwasher or a washing machine does. But that new technology means that we need some more skills. So one of the questions I'm going to ask, and we're going to hope to answer today, is what skills do we need to work with this new technology now and into the future? And our second topic, we're going to talk about revenue as well. So we're going to talk about the fact that there's many tech companies that are, their business model is not large sales of small numbers of products, but they're individually selling 1 and 2 items of a few dollars each through eBay or through digital purchases, and they need systems to keep track of all of these millions of sales. We also have governments and authorities like water authorities and telecommunications or power authorities that manage asset networks with millions of pieces in them. So we're talking about cabling, we're talking about road, bridges, drainage assets. And so this is a big data problem in terms of how do we effectively manage and maintain maintenance across those assets? How do we even visualize what our network looks like? And again, what skills do we need to manage situations like this in the future? If we've got big revenue coming in from lots of small purchases, or we've got millions of customers in our database, or even just millions of data points on data that we've paid for of our potential market, how do we analyze and process that data? So that'll be the second prong of our 3-prong presentation today. And our third prong is recreation. So I'm going to look at the way in which movies, TV shows, and video games are using computer skills. So very much more so in recent years, even than 10 years ago. I think, Lord of the Rings was 20 years ago. There was a bit of CG in the second movie, a fair bit of CG across all movies, but it was pretty new for there to be that much CG. I'm going to talk about the way that the bar for entry, the ability for really small operators like myself or you guys in the audience with minimal training can produce some pretty high quality TV render and movie quality outputs. So we're going to talk about why it's so easy to do that, and we're going to talk about again the skills that we need there. So those are our 3 prongs. We'll get into prong 1. We'll start talking about robots, and I'll just open with actually just before that we've got a note on careers. But are there any questions before I start pronging it up?
I've invited people, if they would like to ask anything of Adrian during the session, to put questions in the chat. So do feel free to do that as we go along. No questions so far, Adrian.
Wonderful. Okay. So I'm going to talk a little bit about jobs of the future. Has anyone seen this stuff here? There's been a I can't remember which university it was, maybe Deakin, I want to say, but a university has looked at 100 jobs of the future and has, some of these have some pretty crazy names that are quite interesting. So the first one on the list there, robot ethicist. We have to think about the ethics of how robots are used and what it might mean to create a potentially self-aware consciousness. Thankfully, at least in principle, Isaac Asimov has done a lot of the hard work for us, decades ago, but we still need to think about how that looks in practice. And then there are other names in there. Trend watcher, you can sort of put together, exactly what that thing means. But then there's some other of these jobs of the future where their name doesn't really tell you a lot about what it might be. So for instance, we've got data waste recycler at the top of the second column there. So this is, if I remember correctly, someone whose job would be to take data which has been processed once. So perhaps if we're talking about, say, social media data, click-through habits and that sort of thing, it's been used once for its primary purpose, but then we need to see, well, who else might use this data? It's not recycling in a traditional sense because data is infinitely copyable and transferable, but this is about trying to understand, once we've already gone to the effort of collecting one data set, where else might that data set be useful? Can we sell it, or can we extract further value from it down the line? We have things like predictive regulation analyst. So you'd be very much aware that the way we've traditionally operated as societies and with governments is there is some practice that capitalistic behavior allows us to do. We're able to export waste or produce carbon emissions, and we depend on government to regulate those industries as the need arises. And so as our technology continues to advance, we might need to start to predict what the regulation is going to look like in the future. So this is, again, we're looking at some pretty crazy ways in which we're going to need to be intimately connected with our technology into the future. Okay, so let's start talking a bit about robotics. We'll get straight into our first prong. And I'll just show a quick video. We show this one to students, and I'll mute that, just showing how these robots move around a delivery warehouse. And so I suppose the takeaway here is that this is, I think, the catch of the day. A lot of these automated processes, we have consistent sized tubs on belts. So the placement, the arrival and departure point of those tubs and the way they're handled can be managed by that robotic arm. The movement of these trays of stock around the warehouse can also be automated because they have this consistent sizing. And with minimal input from the humans in the space, they're able to do something really high volume and make it really cost effective. So the margins on each individual sale might be a couple of dollars or cents, but they're able to do these sales millions of times in a month, and so they can sustain these warehouses and these big purchasing practices. And so there's a bit of data science that goes into the screen you're seeing at the moment. This visualization showing the proposed path that each robot takes, so it doesn't hit another robot. And you might think that this is a really difficult problem to program, or that might take somebody months or years of study. I think honestly, with a room of lay people, you could probably step through the process. Once we show someone how you break apart a problem like that into its small enough pieces, you could see that there's really no great barrier to doing it. If you know a little bit of coding, that's a plus, but it's really not necessary. So there's things like this which are a great advantage, and then there's also new areas like this one. If I can load up this next video and chuck it on mute as well. Good, it's already on mute. We're again seeing some new areas where robotic labor is starting to reach into spaces that had been traditionally reserved for humans. So we're about to see a robot bricklayer. Now, bricklaying is a repetitive task, but it's quite skilled labor that also involves a lot of interpretation in most cases. So traditionally, the way you're going to navigate around a site, the layout, reading the plans, and doing fine work like bricking up a windowsill or bricking around surfaces. These are tasks that require a fair bit of input from the bricklayer. But a lot of the overall just laying of bricks, provided that the site conditions are right, provided that we have good truck parking access and the site is flat and there's no one else that we can hit, this is an automatable task. And we may start to see more and more of this as we have, again, we're all very much aware that there are a lot of desire for housing, affordable housing, which is not so easily met in Melbourne and Ballarat and the broader area. So there's a lot of drive for someone to find an aesthetically pleasing, commercially viable output, which is going to produce a house that someone might want to buy. And we might rethink slightly the way that we would traditionally have a house. So rather than having a brick veneer construction, or rather than having internal plaster walls. If we have internal brick walls and people are okay with that, then we're going to be able to potentially use this robotic labor to work through. Or we might use 3D printed housing, which again, concrete is a semi-solid liquid. We can print it up in layers. We can print a house just as easily as we would print a small toy. I mean, the mechanics are exactly the same. It's just a matter of how do we then manage the expectations of the owner and the user to produce a product which is still highly desirable. So what I want to get to in both this example of this bricklaying thing and some of the other robots we'll look at is that it all comes down to a task that is repeatable. So on that note, I just want to ask the group, what do you think might be automated in the future that isn't automated now? And the big hint is where we can see something that is a repeated task. It might be that there's barriers to getting that repeated task to successfully be completed in the real world, but that doesn't mean that it's impossible. And once we knock down those barriers, when we've got smarter robots and robots that walk like humans do, that they can navigate some of those places which had traditionally been human-only areas. So I might see if I can get into my chat. I might see if they've got any messages. Someone's got hanging the laundry, ice cream serving robot at Fed Square, gardening, shopping. Yeah, so shopping's an interesting one in that we already have, the ability to purchase, products through click and collect, but predictive click and collect would start to be a pretty cool thing. I mean, services like HelloFresh are sort of halfway to a predictive click and collect that's tailored around your personal needs. So you don't even put in your grocery list. You just go down to the shops once a week. Your click and collect order is ready because it's learnt over the last 20 clicks and collects that this is probably what you want. Prime Minister, someone's put there. Interestingly, I do a lot of thinking in the shower about how could we develop a form of government that taps into more information broadly, digitally, electronically, but fits into our existing system. Haven't cracked it just yet, but yeah, Prime Minister's not necessarily off the chopping block either. Yeah, interesting there. Hanging laundry, yeah, there's lots of things. Legal and accounting services are rules based, and you know what else is rules based? Programming languages. I don't see why we can't adapt the language of programming to the language of legal processes, the way that it's impossible to do certain things in a well-programmed video game. We might make our law system subject to certain inputs and outputs with a process in between that can't be can't be avoided. That would be an interesting future. So there's lots of potential there. What skills do we think we'll need to, is it Shift F5, I think, to work with, my other little screen's just popped up. Hang on. What skills do we think might be needed to work with robots? Can I get people to please enter some numbers in the chat if you think, if you think programming is going to be really important to work with robots, mathematics will be really important to work with robots. Chuck a 1, a 2, a 3, or a 4 in there as you think is appropriate. And I'm just going to try and fix my screen again. And I'll come back to that. Okay, so again, I'm checking here. We've got some people are thinking all of the skills are necessary, 1 and 5. So we've got programming and teamwork. Yeah. I think that there's, and I'll touch on this shortly, I think that there's a more fundamental skill than just the programming itself. That is really what we're going to need. So I think all of these are in some way useful, but I think it's actually going to be, in the long run, language. I think someone will come up with a kind of a compiler or a way to program robots with your words. They'll be able to interpret what you're saying. You give them an instruction verbally. If you have industry skills, so you understand what needs to be done on a construction site, you know how the team is operating, and you know how to convey that message effectively to a robot in plain English. Not, nah, mate, yeah, go over there, and you just want to look around the corner, and you want to, if you speak clearly, I think the early days, that's how a robot is going to be verbally programmed, then that's going to be a really good skill to have as well. So algorithmic thinking is what we're looking at in in the case of robots. I'm going to have to speed up a bit because I'm a bit behind time. So we've got an algorithm is just a set of instructions to carry out a task. If we have some skill development in learning how to think algorithmically, you might not necessarily need to be a programmer to understand how to deliver those instructions to a robot or to someone from Eastern Europe, for example. So another thing that you might look at, or to give you an example of what I mean by algorithmic thinking, if we're giving a verbal instruction to a hypothetical robot of the future, some sort of robot servant, and we tell the robot either go to the shops and buy a 2-litre bottle of milk, or go to the shops and buy 2 litres of milk, or saying I need at least 2 litres of milk, or that last option is basically telling the robot everything that you're doing and telling it to accommodate you. What do you think might happen in the first instance, in that first dot point? What are some of the errors that we might run into, or what's some of the ways that the robot might fail its mission if we tell the robot, go to the shops and buy a 2-litre bottle of milk? And again, I'll open up my chat and I'll just see, hopefully, actually, if I double screen, maybe I can keep both messages on screen at the same time. So someone says, yep, exactly. It may buy the wrong type of milk is one thing someone said. The first person there said that if they're out of 2-litre bottles of milk, it won't buy anything. So if you say, I need a 2-litre bottle of milk, and there's no 2-litre bottles of milk, but what you actually needed was just some milk, you're not going to get your desired outcome. It could have bought 2 lots of 1 litre. Maybe the milk was in cartons, not bottles, and the robot did not have an ability to buy a 2-litre bottle of milk, so it came home empty-handed. So we need to think about error-proofing our statements. We need to think about, there's a certain intuitive level of communication that a human is going to do for us, that if you're not able to find exactly what you were asked to do, you're going to fill in the gaps, or you're going to call the person that gave you the instruction and say, hey, I can't get 2-litre bottles of milk. Is it okay if I get oat milk instead, or whatever the case is? But so we're trying to think about ways that we can prime robots so that we can build algorithms which are robust. So we don't just want, as I said, don't just want to get specifically a 2-litre bottle of milk. We want to get 2 litres, or we want to get milk enough for 6 coffees, or we want to get, maybe the 6 friends who are coming over, some of them only drink soy milk, and some of them, maybe we're also out of coffee. So you just tell the robot what you're making, and the robot goes and gets whatever else you need. At Ballarat Tech School, we've got a few programs that touch into these thoughts. So we've got our VEX robotics program, Now Humanoid Robot, and the Automation M&M sorter. They all use programming skills and work with some degree of robotics. So the VEX robots are made to pick up and move objects around a space with little clawbot. The Now Humanoid Robot looks at that human-centered design for robotics. So how can we engage with robots that have a human-like shape? And our automation program with the M&M sorter, that is able to give us some insight into a custom-built robot and how we can program that. So we're going to go on to our second prong. So that's a bit of the robotics side. We'll go into the revenue side, data information, and ask what the difference is between data and information. So what can anyone, well, look, you guys are all adults, so you probably know, if we have data, it's raw. It hasn't been interpreted. Information is what we get from understanding data. And we know, of course, that we base decision making on information, we don't base information or decisions on raw data necessarily. We process it first. So data itself is worth a lot of money. That's basically how Facebook make their money, and they are this is present day value, and I think that's American dollars. $527 billion is the value of a company that for everything that it does wrong and all the harm that it does, trades in data and does an amazing job of it. It has so much power over the platform, the people who use the platforms that it promotes, because it knows so much about them, and it knows what will keep them engaged with the platform, and therefore will keep them looking at additional ad time. So managing and understanding data is big money, and it's only going to I think get more, because or be more so valuable and more so a big part of our lives. Because as I already mentioned, you used to go to the shops and do your grocery shopping, and maybe you used one of those loyalty cards like the Woolworths rewards or whatever, which, by the way, is there to collect your data. That's why they give you a discount. It's because it's valuable to them and valuable to you. But in future, if you're doing click and collect, that's even more specific data on exactly how long you spend on each page before you add each item, how much you're deliberating before you're clicking through. There's degrees and degrees of which we can data mine. Our data storage costs are only falling as humanity gets better and better equipment. I remember when I was working for the Department of Transport, we talked about collecting data on the number of vehicles that moved through an intersection. So there are, for those of you who don't know, there's electromagnetic detectors under the road, and those electromagnetic detectors can either detect where there is or is not a car. And someone said it'll get to the point where we won't just be storing information on how many cars went through a particular intersection that day. We'll actually start storing the wave function of the electromagnetic received signal, because a machine learning algorithm might be able to data mine insights into that information, into that raw data, which we as humans couldn't possibly process, but which may show us some deeper trend or deeper behavior and be useful in a predictive sense in understanding our traffic network. And Amazon, you might have heard of this as well. Amazon has an algorithm that will determine when ahead of time, when enough people in close proximity to a particular fulfillment center, one of their warehouses, is likely to buy a product. So they haven't bought it yet. It's not in their cart. They've just seen their previous purchase history and they go, we think that these 8 people are 50% likely to buy this product. Let's move 4 of those products to this warehouse so that it's ready for same-day shipping for those customers. And if same-day shipping is available, they know that customer is more likely to buy it. So there's a lot of, predictive, crazy behavior that it's at the level of fine detail and minutia which humans cannot work with, but that is fine once a human puts that information into an algorithm that can crunch all the numbers, or not even deliberately sets up the algorithm in writing each line of code, but uses a machine learning algorithm to get some desired behavior based on known inputs and desired outputs. So have a look at the data on the page, and you can see there's a series of numbers on here. You're about to see several slides where this same data has been transformed several different ways. So I'm going to ask the audience, what can you say about the data that's presently up on the screen? Let me know what you can tell me about it. Hopefully I can see all of the chat. I'm not getting a lot of comments, at least I'm not sure if I'm seeing any. So perhaps that's because there's not really a lot that we can say about this. But I'm going to click on to the next slide and perhaps get rhetorical from this point on. So what we're actually looking at here, we can see a number of points, and then there's three columns, 0, 0, and some number. So the first, we're going up sequentially, and then we seem to be going up. We've got some other, is it coordinates? Is it purchase information? Well, we've plotted this same information. This is actually X, Y, Z data. So we've plotted this information so that the X and the Y is represented by the position of this pixel, and the Z data is represented by the color. So now we can see that we're looking at a kind of a landscape, and there's one part which is dark and one part which is light, but we still don't know which is high and which is low. We've taken the same data and we've put it into AutoCAD Civil 3D, and we've produced a surface. And now we can see that this part is low and this part is high, and we get a little bit of an impression of what the surface overall looks like. So we've transformed the data into a more useful or more meaningful form. And once it's in Civil 3D, we can perform other operations on it. We can use that software to change the surface and build a road, or to build a dam and work out what the earth moving volumes are. But to understand that volume, we can again show it in another view. So now we've taken that same data, we've moved it into Blender, we've animated it, and we've colored it based on height. So now, as a viewer of that data, this is the most easily accessible data form. And I've displayed this to not because this specific process is a broadly applicable thing that we can do, but because it is always a useful question to ask have I presented this data in the best format? And how else can I make the trends, or can I make the key information most visible? And so this isn't even necessarily the most realized form, or the highest realized form of the data transformation. There's probably other ways I could present this data which are more meaningful to particular uses. But I think it's going to be a very important skill of the future, and even a skill in the present, to know who your audience is and what do they need from the data, and how do you need to transform the data to show something to them. If you're handy with Excel, or you're handy with Power BI, and you can make some nice graphs and things, you're going to be able to manipulate data and transform data into a form which is palatable and absorbable by your average audience. But if you know a little bit of programming skills to back it up, you can do some real so you can do some kinds of transformation which just simply aren't possible without programming, and which let you really represent the data and really tap into some trends that you may not have seen otherwise. I'll skip over Gapminder because we're a bit short on time, but if you haven't seen it, it's a really cool website. If you just Google Gapminder, it's an amazing tool for data transformation. So whole heap of tabulated data, year-on-year data, and it's been made into an animated, a really interesting display. So again, skills needed in big data. I would say the math skills are helpful. Programming and logic is very helpful. Economics and software skills are helpful. Communication really is the most important skill. If you want to know how you're going to present your big data to your audience, you need to know how to communicate first and foremost. At the Ballarat Tech School, we're currently developing a program looking at, I say big data, but what we're looking at really is traffic data. So we're pulling in traffic data from real user-generated statistics through an app that collects and aggregates vehicle movement data, and then we're viewing that through the lens of a road highway bypass. So it's still under development at the moment. We're hoping next year we'll have a program where students can learn about Excel, they can learn about using data, they can learn about road construction, and so that it's not a boring data sciencey slog through spreadsheets, we're making a VR environment where you can see the construction of a road take place, step by step from existing ground to finished surface. So that's a bit of what you see there. Okay, we're going to get stuck into the recreation side of the presentation today, our third and final prong, before we wrap up the session. So if we have a look at the recent Marvel movies, which I think are probably most commonly seen or known about in the in the environment of people who consume digital media, we've seen really amazing effects, digital and visual effects that have been brought into the big screen, but even the small screen as well, as some of the spin-off shows like Loki or Black Widow continue to have high degrees of CGI in their presentations, whilst being delivered without Hollywood budgets. So I'm going to talk a bit about how that's possible and how this has changed. So even if you played a video game 20 years ago, you play a video game that's current, there's the term photorealism gets thrown around a lot, but it's sometimes astonishingly hard to see where the lie is, see where a scene has been created digitally and not part of a real life. So artists are now able to work faster and easier than they ever have before, because there's been a great deal of advancements in the technology to generate these things. So obviously on the back end, someone's written a lighting engine, someone has needed to do a lot of work with sculpting, three-dimensionally modeling all of the objects that you see on this scene and showing how they move around. But there's actually quite a lot of logic and math that goes into this as well, even the creation of this artwork. So have a look at this scene with Robert Downey Jr. as Iron Man, walking cool guy style down the street as his Iron Man suit slowly melts over his body. Now, this is not the sort of thing which you would have an artist manually crafting each piece of that mesh which is being displayed. So the mesh is the the graphical display of the Iron Man suit, and having it update to match the model's motion. We would have instead used a workflow involving motion capture of Robert Downey, then involving several meshes which are laid on top of each other, being programmatically turned on and off in a style that mimics the flowing of water over a surface, so that we get this really cool effect. So that was done because it was faster, easier, and better looking than if you had an artist and paid an artist to do that manually, or to manually touch up the pixels on the screen. But also its advantages because anyone who's seen the other Marvel movies, you know that the same effect is used for Iron Man's wife, and it's also used for Spider-Man. They have the same suits with the same effects, and it's a small tweak to make changes. If they wanted to reshoot this scene, the director says, "Nah, look, I don't like the way Robert Downey takes off the sunglasses. Let's leave them on." If you'd been doing this artwork manually, you would have to recreate that whole scene from scratch. You have to redo all your work. But because it's done programmatically, we can just remocap Robert Downey, and then we can reapply the same texture transformation, and we will have this effect all over again. So it's about this. This comes down to this is a demonstration of an artistic application of a principle in programming, which is about reusability. We want to always write programs that give us the most reusable forms of anything which is being made, because we are frequently going to try and reuse our code, and we don't want to have to maintain multiple versions of copy pasted code, or we don't want to have to manually do this for Spider-Man and manually do it for Iron Man. We want one behavior that takes a couple of different inputs and that gives us a custom output each time. So a little bit more about smart art. Like, this is a skeletal system that is used in programs like Blender and Unreal Engine to control animations. So we have some animated part, and then we've got the user isn't having to do the hard work of updating a mesh. Once we've tied that mesh to the skeleton, we're then able to make changes much more easily than we could, in the past. And so that's really helping us there. Similarly, with this Olympic Rings drone show, I want to point out that the instruction to the drones would not have been manually given for several reasons. Like, it's just not feasible to tell each drone how it has to move in three-dimensional space and where it needs to get. Instead, we would come up with a function, ideally, and I haven't seen the code that this runs on, but I just know enough programming to fill in the gaps. We would have a system that takes a three-dimensional mesh, like the ring's shape, and we input the number of drones that we're working with, and we just tell the drones evenly fill this mesh. And so there are a number of ways that we could break that function down into a sort of volume distribution, and find a position where each drone, makes its way through that three-dimensional space to ultimately occupy this. By the way, my prediction for the future, I don't know how far into the future, 30 years maybe, the holograms and things that we always see in sci-fi movies of the future, I think they're going to be a swarm of tiny drones. I think that's how we will have something equivalent to a hologram. It'll be a swarm of tiny drones that can represent a three-dimensional shape in front of us. Similar to what we've seen there. Okay, so I want to talk about the fact that a lot of the stuff that we've just seen, a lot of this different artwork and a lot of these different effects, they don't actually need traditional programming in the term of written programming, the way that they have in the past. A lot of different software applications are now rising more with node-based programming. So we have our Now robots use choreography software, which is a node-based thing. So you drag and drop in a tool or a piece of a program, and you are connecting up the inputs and the outputs that you want. And the nodes are good in the sense that it maintains good visualization of what the program is doing, and it also means that we can't connect up parts that don't make sense. So I need if I'm printing something, and usually in the context of computer science, printing is a message to the user, that needs to be a text string. So we're using purple to denote a text string, and I can't connect something which is not purple to something which is purple. I also can't connect an output to an output. I can only connect an input to an output. Our green things here are representing numbers, and again, we're only feeding numbers in. So there's lots of programs which we work with in at the Ballarat Tech School which use this sort of stuff. So this is an example of the visual scripting language of Blueprints, shown on the right-hand side of the screen, applied to Unreal Engine. So in the Unreal Engine, if we want to make a behavior, you don't have to write any code. You can use instead this visual scripting language to undertake some behavior in response to the player's action in the game. And this is something that we bring into our into our students' experience when they come for the our scene maker or game maker programs. If they're interested in it, they can learn about this stuff as well. I'm actually currently working on something. So I mentioned that that VR program with the road builder. So this is it open here, and here we've got an excavator and several other bits of equipment. So these have all been articulated. If I move down here, they've all been made to move around. And hopefully my program doesn't crash because it's a bit slow, just using that visual scripting language. So we've got all of these little bits of motion, the motion of the grader, the motion of the wheels. It's all been done with the visual scripting language of Blueprints. And it's capable of doing, Blueprints are capable of doing some pretty complicated behavior. So open in this window, we have, I might show here, or actually it might even be better to show first the cosine rule. For anyone who needs a quick refresher, the cosine rule will give us the angle of one corner or the length of one side based on the other sides of a triangle, so a non-right angle triangle. This is what the cosine rule looks like in Unreal Engine. So there's the arc cos, because I want to get the angle as an output, and I've got my lengths of all my different inputs, lengths squared, a couple of math operations, and finally I take the arc cos to get my angle. So we're able to do, in visual scripting, we're able to do some pretty complicated behaviors, and we're able to get some really interesting outcomes. So in addition to Unreal Engine using visual scripting, we also have visual scripting in Blender. So this is a scene from Blender. On the left is the newly implemented, and this is really new, only a couple of months old, geometry nodes system. And on the right-hand side, this is how changes to the values in that geometry node affect the generated mesh. So I've seen people do some pretty crazy things with geometry nodes, like programmatic power poles, where you can click and drag, you just generate a line on the ground, and that line will, at certain lengths, will generate a pole. That pole will have a random tilt and offset. That pole will also have a cross beam, which has guy wires on it, and those guy wires will have drape based on the overall length of space between the two poles. And this is all no programming. This is all using nodes. So I got a few minutes left. I'll just quickly talk about the fact that we have our Dynamic Digital Designs program. So this is Blender 3D modeling at the Tech School. Again, students can initially learn about Blender, and if they're interested, learn about the nodes, and Scene Maker for Unreal Engine as well, to learn about some of the node use there. So if that strikes anyone's interest, please send students along. But now in the last few minutes that I've got, I just want to talk about what the common themes are in what we've just seen. So in all of these things that we've seen, we had some benefit gained from knowledge of programming, benefit gained from knowledge of mathematics, a benefit gained from knowledge of computing. But the more universal skill, and I sort of touched on it when I mentioned algorithmic thinking, this was asking the right questions. So if we ask ourselves the question of, how can I I'll give you another example that I was working on recently. I wanted to try to make a tank tread mesh, so the bulldozer treads and the excavator treads. I needed to make those in Unreal Engine, or did I need to make them in Blender? And how was I trying to make them, and could I animate them? If I was focusing on the wrong part of the question, which initially I was, how can I make this this tank tread mesh in an animated fashion and bring it into Unreal Engine, I was getting nowhere. I rephrased the question and went, how can I make it look like the tank treads are moving? And what I was able to do in the end was, and I'll slow this right down so we can see it, was I actually have a series of static meshes here. And I'll slow that right down to point 1 and point 1. There are a series of static meshes, and the static meshes simply update in real time. If we're animating that there, sorry, got my keys on the wrong, fingers on the wrong key. Let me just make sure I've got the right object. Can't actually see it moving at all. So let me try a different one instead. That one's static. This one up here is not. So let's grab this and let's left speed 0.1, right speed 0.1. Oh, I see what's happening. I need to stop and start again. So hopefully now you'll be able to see that this mesh isn't actually moving. The gear wheels don't actually line up with the tread, but when it's moving fast, you don't notice that it's not moving cleanly and smoothly. So asking the right question there was a way to get a really good outcome. So not how to achieve this, but how best to achieve this is a really good suggestion. And one of the things that we want to try and really expose students to in coming to the tech school is get them to have some exposure to a broad variety of fields and get them to understand that they might not necessarily know why they're learning about Cartesian coordinate planes in maths, and they might ask the question, the belligerent question, why am I learning this? When am I ever going to need to know this? And what I want to try and point out to people is these are all different tools that you teach your brain how to interpret the world. So if you're even things like playing card games and board games with weird mechanics that you have to get your head around, studying the different chemical, physical, natural, and artificial sciences, studying different languages, or learning to use new programs, all of these things give you different ways of viewing the world, which can help you to rephrase your questions when you get stuck, and can help you to be a more effective scientific explorer of the world around you. Language in particular, I found that to be a great source of knowledge and inspiration. And I think that, again, it can be really easy to think, well, I just want to be a hairdresser. So, why do I need to know about, mathematics and angles? I don't think that any knowledge you gain is going to be wasted. If you want to come up with the optimum way to, set some new fashion trend, you can guarantee that it's not going to be, it's not going to be a hindrance to understand more about some other sciences, chemicals, or geometry systems. I've used up almost all of my time, and I'm sorry if I've got any questions that I'm yet to get to, but let me just open back up and see, are there any other talking points that the people would like to raise, or any questions or comments here? And I've stood still so long that my lights have gone off.
I was just going to say, Adrian, it looked like you were sort of sitting in the dark there.
I was, yes.
There were a couple of comments. I think when you brought up that first diagram of the kind of flow-based visual code, Melinda was asking, what was that, a screenshot out of something?
Yeah, so that first one, that very first one where it had nodes on the slide, that was, I think, just a generic example of what visual scripting looks like. Yeah.
Yeah, cool. I don't think there were any other questions, but it's an interesting discussion because we tend to move on to general purpose programming like Python or JavaScript. Once we get to secondary years, it can sometimes we feel like, oh, that means that visual code is bad or is just for kids. But it's totally not, is it? Like there is so much you can do these days with visual code, and
absolutely.
it can be very powerful.
Yeah, absolutely. I've found visual code is really fast to do simple things, like particularly Unreal Engine. If I want to, because I'm a hobby game developer working in Unity Engine, but also I do Unreal Engine here at work. And I found that one of the differences between the two, if I want to do something in Unity, I've got sort of, millimetric control. I can turn every dial exactly where I want it, but it takes me a long time to set it up. In Unreal Engine, I can very quickly throw together something that works. And it might not be exactly what I, envision, or I don't have that perfect control, but hey, it's all together and it's functioning. And that's one of the advantages of visual scripts.
Mm. Yeah, just a few thank yous coming through. Thank you for those people who've stuck around until the very end of the day as well. It's just been great. And thank you, Adrian, for coming in right at the end of the day. It's been a big day for the teachers attending, and it's really been a great session to end with.
No,
So,
thanks for having me. And yeah, well, look, as I said, I hope to see everyone sending some students through for our programs here. We're wanting to do some teacher PD as well. We just want to try and get interest about what teachers would like to learn more about. So if there's anything you saw today and you thought that looks pretty cool, I'd like to know that to teach my students, or just get yourself a bit prepped up, let us know, and we're going to work to put something together.